Alright, so we're going to look at the expansion of a general a plus b to the n. Okay, so we looked at 1 plus x and we noticed the pattern that follows Pascal's triangle. Now we're going to have a look how Pascal's triangle and the general expansion where a and b can represent any term. Alright, so for example a, expand 5 plus x to the power of 5, so a is 5 and b is x, and n is of course 5. So we set the pattern as follows, equals. So it will be n, really the pattern is following n, c, k, a to the n minus k, b to the power of k. That's the pattern, every value for n. Alright, so in this example, n is 5. So I've got 5c, and then the first value for k, which is always 0. Alright, now a is 5, n minus k, so that minus that is where n and k comes from, to the power of 5, and b, which is x, to the power of k, which is the bottom there. Alright, so the powers will decrease by a constant amount for a, working left to right. So we've got 5, this example is 5, 4, 3, 2, 1, 0. And b will increase, in this example, up by a power of 1 as we go from left to right. Okay, so we've got that pattern consistent. Alright, next value is 1, so 5c1. 5 to the power of n minus k, so 5 take away 1, 4. And we have x to the power of k, which is 1. Five c2, 5 n minus k, so 5 take away 2 is 3, and x to the power of k. So it is really simple once we understand the pattern. And we keep following that pattern right through. Alright, so once we understand patterns better, we can neglect some terms. Okay, so for example, we do know 5c5 0. 5c5 is 1. 5 to the power of 0 is 1. So we can start to identify what I need to write. Okay, but I would suggest heavily that you will write all out so you recognise the pattern. Alright, not getting yourself somewhere making a silly mistake. Alright, what was the answer from yesterday? Monday, so? Oh, we're going to work it out. 3125 plus 3125 x.
Plus 250x
250. 1250 x squared.
plus 250x cubed.
Yep.
25x squared.
Okay. Now, have you guys heard of Wolfram Alpha? Have you guys used Wolfram Alpha? Have you used it for this sort of stuff yet? Right, have you used widgets in Wolfram Alpha? Kim bought a ticket.
Bought a ticket ages ago.
Okay, Bono expansion calculator. Okay, so you can just put in what you want there. Alright, so 5 plus x. There are some calculators that do putting the value of a, putting the value for b, putting the value for n, alright, separately. So you pick the one that you want. Okay, so this is the way you can check your work. Alright, and of course it's going to be back to front, this one there, okay? Doesn't matter the order, we'll just obviously look consistent in the order, but it'll give you your solution set, okay? So that will be a handy feature. Rather than checking the back of your books, you can just get on your iPads or computer or whatever and put the thingo into one of these widgets and do the expansion, okay? So that's a nice little feature there. Alright, 2x take away 3 to the power of 4. Right, so we've got the negative in there, so what we need to do is include that negative with b, and that will take care of all the signs that you need. Right, so n is 4. So remember the rules, n, c, k, a to the n minus k, and b to the k each and every term. Alright, so you go up from k from 0 to k equals n take away 1. So, k equals n. Alright, so 4c0 of 2x to the power of 4 take away 0 and negative 3 to the power of 0. Okay, and of course we can put that into that widget or any other calculator. You can even just put it in Google and it'll do it for you, I think. In that search bar, you might even need to do it there for you. But I like Wolfram because that's really a lot more detailed to what Google will offer you at the moment, okay, in some areas. Right? I think Google's doing its best to catch up. Okay, we won't write the answers because we've done that last lesson, but we're just getting familiar with the process again. Alright, so we have also fractional values for a and or b. Alright, so you just got to include that fraction. Okay, so remember 1 on x is equal to what? X to the power of negative 1. Okay, that will just help you with your powers to powers. Alright, and then you can rewrite it. Or you can just write it like that. Okay, it's up to you. Alright, so n is 3, so 3c0, so 4x squared, all to the power of 3 take away 0, and x to the negative 1 to the power of 0. Alright, so I've rewritten like that just to help me with my power to a power rule in x notation. Okay, you will also notice this one, when you expand it out, won't have increase or decrease by powers of 1, and also it will be a different chain because both terms are with the power of x. Okay. However, the pattern will be consistent right the way through. My duster away. Thinking bad habits. 4x squared to the power of 3 and x to the negative 1. How's that? Okay, so we're remembering the patterns. Okay. That should be 3, that's why. 3c3, I did it based on that. Okay, so that will be to the power of 0, and that's 3. Good. Alright, so let's move on to the question we're up to. Alright, so if 3 take away the square root of 2 to the power of 4 is equal to capital P plus capital Q root 2, we need to evaluate the values of P and Q. Right. Right, so you need to set up your expansion. Okay, so what can we do from here? What's your thinking? Well, what is negative root 2 squared? What is negative root 2 to the power of 4? Hey? Well, 4 is 2 times 2, so negative root 2 squared is 2. 2 squared is 4. This is easy stuff, guys. What is, well, that's 1. Okay, what is negative root 2 to the power of 1? Alright, what is negative root 2 to the power of 3? Okay. Negative 2 root 2. Okay, because this is negative root 2 times negative root 2 times negative root 2. Okay, so it becomes a negative 2 root 2. Alright, so every second term is going to have a root 2 term. Alright, and then every alternating term on the side of that is going to be a constant term because of the even power of x. Okay, let's delete enough space. Nope. Alright, so let's group it. Alright, so we've got 4C0, which is 1, 3 to the power of 4. Good. Alright, negative root 2 to the power of 0 is 1. Alright, 4C1 is 4, 3 to the power of 3. 27, and then you have the negative root 2. Alright, so negative 27 root 2. So, because this is 4 times 27, sorry, I've got to multiply by the 4, 108 root 2. 4C2. Pascal's triangle. 1, 4. 1, 4. What's 3 and 3? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and then that's the next row you need. 1, 4, what's 3 plus 3? 6. 6 times 3 squared. So 3 squared is 9, 6 nines are 54, and then negative root 2 all squared is 2, so 54 times 2. Okay? Hey? No, it's not. Glad you answered your own question before I slapped you. Okay, so now we have 4C3, which is 1, 4, 6 symmetry.
6.
There's how many terms? In a 4,
6.
in a expansion of 4, power of 4 is n plus 1, which is
4.
when you have the expansion of something to the power of 4, a binomial to the power of 4, how many terms do you have? n plus 1, which is 5. So you have 5 terms. So 1, 2, 3. So now we've got symmetry. This coefficient, 4C3, must equal the coefficient 4C1
4.
on your symmetry of Pascal's triangle.
4.
So 4C3 is the same as 4C1. So 4C1 is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Using Pascal's triangle. Okay? Too early in the morning, is it? Right, so 4 times 3. 12. What's negative root 2 to the power of 3? Negative 2 root 2. So 12 times negative 2 becomes negative 24 root 2. And 4C4 is 1. 3 to the power of 0 is
1.
negative 2 root, negative square root of 2 to the power of 4 is 4. Got there in the end. Alright. So, need to add them together now. Like terms. So, 81 plus 108 plus 4.
181. Wait, no, that's a plus.
Yeah, there's still.
No, it's a plus, so it's 193. I don't know why I thought before.
Yeah, so that plus 100 plus another 8. 193. So negative 108 take away
No, I thought it was a negative 4.
24. I'm on fire this morning.
Negative 132. That's a square root of
Okay, so remember the question said this is equal to P plus Q root 2. So what's the value of P and Q?
No, P is 193.
You did say negative 132 for Q, didn't you? Good. Right, question. What is the fourth term of the expansion of that? So am I going to do the whole expansion?
You're probably. We are. Not you.
You not be using up your time very efficiently or if you do the whole expansion. Okay, realistically, what do I need to expand up to?
9C3.
Hey? Oh, I just need to do that, don't I?
9C3
Yeah. Because the first one will be 9C0, second one will be 9C1, third one will be 9C2. So we need to use the concept of NCK, A to the N minus K, B to the K, where K is going to be 3. Alright. So term 4 is going to be 9C3 times 3x squared to the 9 take away 3 and 5x to the power of k, which is 3. What is the fourth term? Alright, 9C3 times 3 to the power 6 times 5 to the power 3.
9C3 is 84.
So,
9C3 is 84.
yep, so times 3 to the power 6 times 5 to the power 3. Okay, at this point I would just put that all in your calculator. Okay, I wouldn't waste time doing every little bit. Alright, digit by digit. Right, I should probably do it this way. Alright, 7,654,500 x to the power of 15. And that's just the fourth term. Alright, another application asking to find a decimal correct to another certain, represented as another decimal obviously to a number of decimal places. So, using the concept of binomial expansion, how am I going to set this particular question up? So what have we been doing this topic? The expansion of what? Yeah, which is what in formula? Yeah. So I want to expand that using that concept. So how can I set it up?
0 plus 0.
So, what did you say?
0 plus 0, 9, 8.
You could do it that way, however, there would be a better way to set it up as?
1 take away 102.
1 take away 0.02 to the power of 5. Because doing the expansions of 1 is going to be easy. Okay. Alright, so 5C0, so I don't really need to worry about 1s out the front because 1 to any power is going to be 1. I just need to concern about the B term. Okay, so I can use my mathematical understanding reasoning to make things a bit easier for myself. Right, I'd whack that all straight in the calculator as it is. Okay, not bit by bit, I just put it all in the same calculation. Come on.
You have a calculator here.
Oh, I do.
It'll be a lot quicker.
It would be a lot quicker, but you won't have me in the exams, won't you? Or me during your homework tasks. Hey?
What are the settings?
0.02%.
You have to restart.
Oh. Alright, 1 take away 0.02 to the power of, what was it? 5?
2, 5, 5.
Alright,
Almost 2 minutes long.
There's really nothing wrong with it. Where was that exclamation mark? That wasn't. It's a 5. Yeah, it's all in.
might have to put a multiplication between the 5c5 times, probably taken as 5c by the outside of negative 0.02. So you probably have to put a times next to it. Alright, 4 decimal places. So 0.93292079668. Alright, that 4 decimal places. 9039. 4 decimal places. Okay, now realistically, yes, we put 0.98 to the power of 5 in the calculator rather than doing the whole expansion. Okay, but if they're going to ask you to do this, particularly doing a set and up add binomial expansion, that's how you need to do it. Okay, question?